Another example using the equations of kinematics. In this case, I have a ball, and I'm going to throw it up with an initial velocity of plus 10 meters per second. And so that positive sign means that I've taken up to be my positive direction. I just need to use that consistently. Once I've made that choice, I want to keep using it. And a couple things that we're asked to find out. How high will the ball go? And how long is the ball in the air? Okay, so I want to answer both of those questions. Let's start off with my inventory of what things we know and what things we don't know. Try to give that some thought. If it is one-dimensional motion, there are going to be 7 variables in the kinematics equations, and if you introduce more dimensions, you're going to bring in an additional 6 variables for each additional dimension. So time is common between all, but you have to represent the different positions, the different velocities, and possibly different acceleration for each dimension in space. And this is a one-dimensional problem, so we just have 7 variables. So we have an initial time, a final time, an initial position, a final position, an initial velocity, which that was given is 10 meters per second, a final velocity, and the acceleration. Okay, so let me fill in the rest of that inventory. I can pick when I start my clock to be at a time of 0. For the final time, we need to solve for that to answer the second question. The initial position I can pick to be 0. Then the final position, we need that to answer the first question, how high will the ball go? So that's an unknown we need to solve for. V final is not given in the problem, but we do actually know what its value is. At the highest point that the ball is going to go, that has to correspond to a velocity of 0. So otherwise, it's not the highest point. If my final velocity is positive, it would still be moving up. It hasn't reached the highest point yet. If my final velocity were negative, it's already on the way back down. So right at the highest point, the velocity has to go through 0. So it's at rest for just an instant. All right, and then I picked up to be the positive direction. So that tells me that the acceleration due to gravity is minus 9.81 meters per second squared. And everything will work out. You'll get the same motion consistent with your coordinates if you, for example, pick down to be the positive direction. You just have to make a statement about what you're assuming your coordinates to be, and then just use it consistently. All right. So let's answer the first question first. How high will the ball go? So I want an equation of kinematics that has x final in it, but does not involve the final time, because I want to have only one unknown to solve for, and that's going to be the fourth equation of kinematics, which tells me v final squared minus v initial squared is twice the acceleration times the displacement. I picked x initial to be 0, so it's basically saying where the end of my ruler is. So delta x is the same as x final. And there's another simplification I can make because I know that v final along the x direction is 0, so I can throw out that term. So it simplifies a bit. Let me rewrite things a little bit. 2 times the acceleration along the x direction times x final is equal to minus the initial velocity along the x direction squared. And we're going to solve for x final, divide both sides of the equation by 2 and by the acceleration. So x final is going to be minus v initial x squared over twice the acceleration. We can put in our values for that. So we have an equation with the thing we want all by itself on the left, and everything on the right hand side is known. So I know I'm all done with my algebra. I'm ready to compute something. So I have the minus sign. In the numerator I have 10 meters per second quantity squared. In the denominator I have a 2 and minus 9.81 meters per second squared. And that's going to give me 5.10 meters when you calculate it out. So that's how high the ball goes. Just a little bit over 5 meters. How long is the ball in the air? To use that, I'm going to try to be careful with my variables a little bit. So delta t, t final, which that corresponds to the highest point, minus t initial, which we took to be 0. I'm going to call that the time to go up. Okay. Using the definition of acceleration, we have v final along the x direction at the highest point is the acceleration times delta t plus v initial along the x direction. And that is going to tell me to substitute in t up for delta t and solve for it. And I'm going to have v final along the x direction minus v initial along the x direction over the acceleration along the x direction. And that at the highest point is 0. So I'm going to have 0 minus 10 meters per second over minus 9.81 meters per second squared. It's going to give me a time to go up of 1.02 seconds. And that tells me the total time in the air is twice that. 2.04 seconds. Because it'll be 1.02 seconds to go up and another 1.02 seconds to go back down. Because the motion is going to be symmetric if gravity is the only force that's acting. So there we have it. We know how high the ball is going to go. We know how long it's in the air. And we've filled in everything in our inventory.